Okay. Good afternoon, class. Okay, in today's class, we are discussing regarding the simulation flow. Whether we are using VHDL or Verilog HDL, whatever the case may be, both are hardware description languages only. We will be following the same type of flow. Okay, simulation flow. Okay. Before going into the steps, first we will discuss the general flow in the digital designing of VLSI. You can see first what you'll do is first you keep your idea on a paper, and then what you do is you will identify what are the components required for it, and you will write the individual programs for each component, and then to satisfy your idea what you will do is you will use those components what you have, or for what you have written the program, and you will interlink all those components, and finally main your main theme will be satisfied. That means your idea will be satisfied. That is the general thing. During the process, what you will do is first you will write the hardware description language code, and then you go for simulation. Okay, you go for simulation, and then you go for, that means meanwhile what you do is first you will check the syntax, and you will verify the syntax. If it is okay, until it is okay, you will be changing the syntax, and once the syntax is okay, then you will go for the simulation. When you go for simulation, you will be identifying the output. Whether you will be for the known inputs, you will verify for the known output, right? That means you are just verifying. You also know the output, but just you will verify whether it is working properly or not. That change in the inputs, corresponding output is changing correctly or not. You will be identifying that. That is the simulation. That means you are verifying the functionality. Then afterwards, what you will do is you will go for synthesizing it. That means synthesizing is nothing but identifying the relation between the both. That means between the components. That is called as synthesis. You will identify the relation, identify the relation between the one and the other blocks. Okay. After that, if you got a proper synthesizable code, then you can synthesize it, and then you can implement that the total content on the FPGAs, that is called as field programmable gate arrays, right? You can do the thing. You can verify on the field programmable gate arrays. Once you can work on this FPGA, that if it is okay, then we can further go for the implementing that one on the analog part, right? You can implement it on the analog part, and you can have the hardware done, right, by making the masks. That's the general flow what we'll be using in your VLSI, right? So what are the hardware description language, maybe either Verilog HDL or VHDL, whatever it may be, the process up to verification on the FPGA will be the same, right? In that time, meanwhile, you'll get this simulation concept. So in that simulation concept, here we have the simulation flow like this. First, we'll have some simulation time. So the total simulation will be carried out in some particular amount of time, that is called as simulation time. Okay, the simulator functions with simulation time advancing in discrete steps, right? The simulator functions with, with simulation time advancing in discrete steps, right? Actually, you know that in VHDL or Verilog HDL, all these statements will be executed at a time. And the previous discussion also we have said that. So we are using here always blocks or some other blocks where that some set of statements has to be executed in sequential order. Since we are we are writing the code with the help of behavioral modeling. In the behavioral modeling, we need some of the steps to be executed in the sequential order. Right. So in the simulation process, in the behavioral modeling, what we are discussing right now, in the simulation step, a number of active events are sequentially carried out. Okay. So the simulator maintains an event queue called as stratified event queue. Stratified event queue. Okay. It will be having an active segment in its top, and this topmost event in the active segment of the queue is taken up for the execution next, right? Okay, that means some part of statements will be combined as one, and it will be having some label just like that. That label based on the after what it has to execute, right? After that, after execution of this so and so statements, it has to go for the next address, right? um, what you say, well, what is the next statement has to be executed, it has to be mentioned there, right? So these active events can be of an update type or an evaluation type, right? These evaluation events can be for evaluation of different variables or some values or some nets or some other expressions also. Okay, so refreshing the queue and rearranging it constitutes the update event, right? So any updating can also call for subsequent evaluation. You can clearly understand this with the help of a flowchart. So you see here, we have a start here, we have a start. After that, it's going for A. Here we have any events. Okay, if you have any event, if yes, you have to go for verifying it. If you don't have any event, then you can end your simulation. But if you have an event, you have to go and see whether it's an active event or inactive event. So if it's an inactive event, you have to activate all the inactive events and then it has to go for verifying once again, and you have to activate once again the inactive events. Okay. So if we can have some non-blocking assignments also, we can have some non-blocking assignments also. We can activate them, or else if you don't have any blocking assigning assignments, you can monitor those events and you can activate them, or you can go for advanced simulation time and you can activate all the inactive events at the next time steps and you can update those events. Okay, so what is this is just you are in when you are going for simulation, you are activating the inactive events and you are making them executed, right? So just it's a very last thing after this exercise we don't have. Okay. It's the end of the chapter. So this is the stratified event queue. Okay, stratified event queue. The events being carried out at any instant gives rise to other events, right? Inherent in the execution process. So all such type of events can be grouped here in the five types. One is active events, which we have just discussed there. Inactive events are just, you can see, the inactive events are the events lined up for execution immediately after the execution of the active event. So inactive events will be there, so they will be executed after the execution of the active event immediately. So these inactive events are nothing but they will be having a zero delay. Okay, events specified with zero delay are the inactive events. Right. We can have blocking assignment events. Okay, we have some blocking assignment events, operations and processes carried out. So stratified event queue. Okay, just we have seen the we have already seen the concept of zero delay also, right? So these are the zero delays. Events specified with zero delays are called as inactive events. Okay, blocking assignment events are also there, right? Operations and process carried out at previous time steps with result to the update at the current time step or the category, right? Okay. Monitoring events. We can also have some monitor events, right? The monitor events at the current time step. Generally, we used to mention dollar monitor and also dollar strobe. These are processed after the processing of the active events, inactive events, and non-blocking assignment events, right? Okay. In the flow, in the program also you can see you are using this monitor statement at the last. After the monitor, you will be using the stop or finish statements, right? Blocking assignments, non-blocking assignments, okay, active events, inactive events. This is the general flow, what has to be added in this stratified event queue, right? We can also have future events scheduled to occur at some future simulation time are called as the future events. We just see how many we have five varieties of events. One is active events, inactive events. Active events are the one which has to be performed at the first. Inactive events are the one which will be generally mentioned with a zero delay, hash zero. That is nothing but the zero time delay, right? That will be executed after the execution of the active events only. Blocking assignment events. This will be operations and the processes carried out previous time step with result to an updated the current time step of this category. Okay, this one will be based upon the current time update. Okay, monitoring events. You can see monitoring events. These are at the current time step only. We used to use the dollar monitor and dollar strobe. Okay, just to monitor different types of activities performed. Right. So this will be processed only after processing of these active events, inactive events, and non-logging assignment events only. Correct. Next, future events. We can also have some future events. Further, that means in the for loop you can see, um, we are writing I plus plus. That means it has to in near future it has to perform once again increment on I. Okay. Yeah. So this is the flow chart. You can go with it once again and you can understand this flow chart. Okay. So these are the exercises. Okay, that is what we have learned so far using positive edge clock, negative edge clock, wait statements, case statements, initial, multiple initial, delays, intra delays, all these. Okay, so you can have we have already seen this, right? If else, right? We have modeling part two also we have seen there. These things also we have seen in the previous class, right? Display there at the point of time we have missed the simulation part, and that one is clarified right now, right? SN and DSI. So for repeating some particular point of statements, we use this repeat statement. Generally, we use in the for loop. Right? Disable. If you want to disable some part of the program for particular point of time, you can use this disable statements also. So actually, okay. In the next class, we have this concept called as while loops. These all things we have seen in the C language and also in the PHP also. While some expressions, some statements. So while do while we have this, right? Okay, anyhow, we'll see this in the next class.